In May of 1981, my family and I attended the California State Railroad Museum's grand opening in Sacramento, California. One of the operating locomotives that was under steam for the event was a massive piece of machinery from the Union Pacific Railroad with even a larger sounding whistle. A whistle that commanded respect and was the sound of steam's superpower era. Little did I know that more than 40 years later, we would be helping to preserve that sound. In 1943, the American Locomotive Works was building their second series of heavy hauling locomotives for the Union Pacific Railroad. The engines would be over 120 feet long and weigh in at over 1 million pounds. The locomotives were articulated to negotiate turns on the main line and were more powerful than just about anything else on rails at the time. And they were given the name Challengers. And they quickly became an integral part of the UP's Superpower Steam program. The engines were finished with their service at the end of the steam era in 1957, and all but 2 were scrapped. In 1979, a group of railroad volunteers restored one of the remaining engines back to operating condition in time to attend the opening of the California State Railroad Museum, and this is where I heard the mighty sound of the Hancock 3-chime for the first time. The Union Pacific Railroad selected Manning, Maxwell & Moore's Hancock Inspirator Company to supply the locomotive's voice. It would become known as the Hancock Long Bell 3-chime. The 3985 would spend the next 30 years operating on the UP system, and in 2010 would end her service on the Union Pacific. The locomotive would be donated to the railroading heritage of Midwest America in 2022, where she will once again be restored to operating condition. The Rizzoli Locomotive Works was honored to be chosen to restore the 3985's Hancock Long Bell. This is the story of giving the Challenger her voice back. In late 2023, Rizzoli Locomotive Works was contacted by the Railroading Heritage of Midwest America to restore the Hancock 3-chime assigned to the 3985. The whistle arrived at our shop and some minor damage was immediately visible, but we couldn't make a complete assessment without taking the entire whistle apart, and it quickly became apparent that we would need bigger tools to get this very stuck whistle apart if we were going to make any repairs. 67 years of thermal cycling and bouncing around on top of a locomotive made sure everything was as tight could be. So it was off to my brother's shop in the Sierra foothills for bigger tools. Heat, pressure, and a lot of elbow grease finally got the job done without damaging any of the original materials. Once all the pieces were apart, we returned to our shop for cleaning and inspection. The first thing that was apparent was the bowl had been crushed by the fulcrum arm at the pivot point. The arm was over-traveling when released from blowing, hitting the bowl casting, causing it to get pinched against the languid plate. This will cause one of the notes of the whistle not to sound correctly. The next issue was the steam cutting of the languid plate that occurred at a couple of locations around the edge. The first step in the repair was to chuck up the bowl in the lathe and machine all the surfaces flat and true to the center support. Once everything was running square, measurements were taken to make a pattern for a new languid plate. The pattern was created and sent off to the foundry for casting in naval M bronze. While the foundry was pouring the languid plate, we turned our attention to the valve. This turned out to be a tremendous research project to determine the best material to be used for the poppet valve. The valve we removed from the bowl was cast steel and not the original poppet from 1943. It had some major repairs and was converted from a later model Hancock whistle. The decision was made to replace the poppet with the correct valve for the year of manufacture. After a lot of research and conversations with others in the know, we made the decision to use naval M bronze for the new poppet. We made a pattern and a core and sent them off to the foundry. While we waited, The languid plate casting had arrived, so finish machining could begin. The new plate was fitted to the bowl, and the steam admission slit was back to factory spec. Before we could machine the new poppet valve, the bowl needed to have the valve face cleaned up and the bore for the push rod renewed. The guide for the push rod was way out of round and very loose. We bored out the bowl's valve guide and made a new bushing to be pressed into the casting. This brought the tolerance back to spec. The poppet valve was then machined to factory drawings and fitted to the bowl. We did make one small change to the poppet by moving the spring into the bowl instead of using a tapered spring on the push rod. This is a better design that will be easy to replace if ever needed. The final task was to install a steel bushing on the fulcrum arm. The hole was egg-shaped and way oversized, so we bored out the steel arm and pressed in a new steel bushing. While the pieces of the bowl were laying on the bench, the 3985 stamp was clearly visible, and I was immediately reminded how fortunate we are to be working on such a wonderful piece of railroad history. Once everything was complete, we took the whistle up to the Virginia and Truckee Railroad for a steam test of the new valve and to hear the voice of the challenger come to life. We can't thank the railroading heritage of Midwest America enough for allowing us to help with the restoration of the mighty 3985.